Hi, future doctors. Welcome to the next class. In this class, we'll discuss about law of conservation of energy, LCE. So, this statement you came to know since our childhood. What does the statement means? Energy neither be created nor be destroyed, but it can be changed from one form to another form. So, what is that one form to another form? So, if you switch on the fan, so fan is going to be rotating because of electrical energy. That electrical energy is converting into rotational. Rotational means mechanical energy. So how much electrical energy you are supplying? Same amount of mechanical energy it is rotating. Next, whenever it is rotating, it is going to give wind plus sound, wind energy plus sound energy. So, but total energy is always constant. So that is only total energy is always constant at each and every position wherever you go in the universe. Total energy is going to be constant. So in case of freely falling body from some height, it is moving from A to B. You drop the object from H height. So what is the total energy at A means? At A, potential energy is mgh. At A, kinetic energy, because initial velocity is 0 of m u square. Kinetic energy is 0. Then what is the total energy at A? mgh plus 0, because total energy at A is potential energy plus kinetic energy. Therefore, total energy at A will be stored in the form of potential energy. So, after reaching B, what is the potential energy at B means? There is no height. Therefore, mg into 0. What is the kinetic energy? Kinetic energy at B of m velocity at B square. So, what is the velocity at B? If an object is dropped from h height, velocity after reaching ground is root 2gh. Therefore, root 2gh whole square. So, half m 2gh. Therefore, 2 2 will be cancelled. Again, you got mgh. So, total energy at A mgh. Kinetic energy at B mgh. Potential energy at A mgh. This mgh is converting into kinetic energy, but that is also equal to same value, that is mgh. Therefore, total energy E at B is equal to potential energy plus kinetic energy. Potential energy 0, kinetic energy mgh. Therefore, total energy is also mgh. Not only at A and B, at any point in between A and B, total energy is going to be constant. If initially 10 joules of energy is given, so at each and every point, total energy is 10 joules. But at initial point, it is in the form of potential energy. At final point, it is converting into kinetic energy. But total energy remains constant. This is only law of conservation of energy. So where we will apply problems, how we are going to apply problems on this means, they will give like this. An object is moving from 40 meters height at A. Initially starts from rest. So it is reaching like this. After reaching B to height 10 meters. What is the velocity at B they will ask. So in this case, so we are going to apply law of conservation of energy. Not only in this case, in so many cases we can apply, but you should come to know where we are going to apply after reading the problem this law of conservation of energy. That is going to be challenge. Initial velocity height, final velocity we should calculate height they gave. Therefore, by seeing this height, you should get idea potential energy, kinetic energy we have to apply, that is law of conservation of energy. Total energy at A equal to total energy at, now what is total energy at A? UA plus KA, UB plus KB. What is potential energy at A? mgh. What is the height here? 40 meters. Kinetic energy at A of m 0 square. Next, potential energy at B. mg 10. Kinetic energy at B, half m vb square. So you can cancel all the m's in this. This is obviously 0. We cancel all m's, 40g is equal to 10g plus vb square by 2. Now vb square by 2 is equal to 30g, correct? 40g minus 10g. If you send this side, vb square equal to 60g. G value if you are taking 600, then vb is 10 root 6 meter per second. Isn't it visible? So like this we are going to calculate. Next, if somewhere they are asking here, so they may ask velocity, they may give height, 5 meters, what is the velocity? Otherwise they will give velocity, what is the height it is going to reach. So we are going to apply law of conservation of energy. So at the same time, an object is dropped from certain height. Initially, it is having 10 joules of energy. After reaching ground, it is having only 2 joules, let us assume. Then, what is the work done by resistive force, they will ask. So, after reaching ground, it should have total energy how much? 10 joules. But after reaching here, how much energy is there? 2 joules. Then, how much wasted? 8 joules. This 8 joules only work done by resistive force they are going to give, isn't it? So this should be very careful while reading, while doing problems. You will be getting all this. At that time, you will be getting idea. So next, an object is falling on the spring like this. Spring is going to be compressed. At this time also, we are going to apply law of conservation of energy of kx square equal to mgh. How we have to apply? We will be getting in problems. I am saying how to apply law of conservation of energy. So whenever they are giving like this, you should apply. So if you learn this concept, you can do problems also very well. If object is moving in circular path, so this is the reference point. Total energy at A, B, C at any point, you can equate. Potential energy plus kinetic energy is always constant. We are going to write potential energy plus kinetic energy at any point whenever object is rotating. So we will apply all these in upcoming cases. We will see, but you should be very careful with this law of conservation of energy statement and application of this statement. Thank you.